Now we're going to start rational expressions and their simplifications. Excluding values from rational expressions. If a variable in a rational expression is replaced by a number that causes the denominator to be 0, that number must be excluded as a replacement for that variable. The rational expression is undefined at any values that produces a denominator of 0. Find all the numbers for which the rational expression is undefined, and the clue is right here. Take your denominator, set it equal to 0. So in this particular problem, x cannot equal 4, because if you substituted that back in, you would have division by 0. So it's excluded. Let me get my denominator. This is a trinomial that has a coefficient of 1. So 1 times negative 10 is negative 10. That's the pairing I need. Those two numbers would have to be excluded from the domain. Simplifying rational expressions. Factor the numerator and denominator completely. Reduce or cancel any common factors. In this particular problem, I have a binomial up top, and I can factor out a 5. The denominator is a monomial, and monomials are made up of factors. Now, if you will check this fraction out, 5 will go into both top and bottom. And that is all that I can do for that particular problem. In the next one, in the numerator, I can factor out x squared. Leaves me x plus 1. If you have a binomial that you can't factor, put it in parentheses, so that way you'll be able to see which ones you can cancel out. Since my denominator canceled out completely, it's understood to be a 1, so in this problem, my answer would be x squared. In the next one, I will always go to binomials first and factor them because they're fast. The top one is one of those nice trinomials. 1 times 5 will give me 5. And that's exactly what I need. So the factors that are the same are the x plus 5s. So I'm left with x plus 1, x minus 5. Factors that are opposite. The quotient of two polynomials that have opposite signs and are additive inverses is -1. Well, what that's referring to, my suggestion on these, and you can see them if you will do this, get them in standard form or descending order, because they always write these type of problems in this fashion. Now in the numerator, I've got a difference of perfect squares, so let me go factor that. In the denominator, I'm going to factor out a -3. And that would give me a 2x minus 5. Remember, when you factor out a negative, your signs change. So I do have a binomial that's a common factor. If I did not pull out that negative, I would not have been able to factor anything. But first, rewrite them in descending order, standard form, and then factor out a negative. So that's it for this one.